Hi all, I'm Agna and I'm dealing with the topic cytology in taxonomy. So, taxonomy was initially based mostly on morphological and anatomical features. However, in the second half of 20th century, it took quantum leaps and fast strides and adopted a synthetic approach based on the data and information provided by other branches of biological science such as cytology, genetics, molecular biology, biochemistry, and so on. Consequently, several new branches of taxonomy emerged. The important ones among them are cytotaxonomy, chemotaxonomy, molecular taxonomy, and numerical taxonomy, etc. So, what is cytotaxonomy? Cytology has made an outstanding contribution to taxonomy during the last few decades in the elucidation of many taxonomic problems. Cytology, which includes the study of the cell, or more appropriately, karyology, the study of chromosome. These all made significant contributions in taxonomy. So, cytotaxonomy is the utilization of the cytological characters in the elucidation of taxonomic problems. So, uh, the cytotaxonomy deals or the chromosome characteristics used in most cytotaxonomic studies include first one is chromosome number, then chromosome size, other one is chromosome morphology, and the last one is chromosome behavior at meiosis. So these four are the common chromosome characteristics used in most cytotaxonomic studies. So since these characteristics are derived directly from nucleus, they collectively yield informations which can be used in understanding evolutionary relationship among the taxas at various levels. So we can come to each and every single topic. So first one is chromosome number. Usually all individuals within a species possess the same chromosome number. Likewise, when we can say there is variations or constancy in the chromosome number within the taxa of different categories is an important character for taxonomic groupings. So uh, when we look into variations, we can see that however there is the majority of them sorry, so the majority of angiosperms show a range between the the haploid chromosome number. There is a range between n is equal to 7 and n is equal to 12 in majority of angiosperms. Then we can see the highest chromosome number recorded from vascular plants is that it is from the pteridophyte. It's Ophioglossum reticulatum. It has the diploid chromosome number 1260. So there is many variations among species. Then we can see some constancy relations, that is the chromosome number in some plants remain constant in all species. For example, in the species of pinus, there is the haploid chromosome number n is equal to 12 chromosomes. These numbers is called as the constant chromosome numbers. So they are of course of limited importance but are useful in knowing a particular genus. So it is all about the chromosome number in cytotaxonomy. The second one is chromosome size. The chromosome size has been very useful in understanding relationships in several taxa. In most plants, the length of a chromosome varies from zero point 0.5 to 30 micron. So when we look into monocots, the members of Zingiberaceae possess small chromosomes. Then the members of Iridaceae have small to medium sized chromosomes. Then the members of Amaryllidaceae have large sized chromosomes. And when we look into Liliaceae, it has chromosomes of varying size. So these these all have many variations in chromosome size. So this it is very helpful to taxonomic studies. Then the other one is chromosome morphology. Usually, the chromosomes are characterized as median or submedian, subterminal, or terminal with reference to their length and position of its centromere. So, the centromere location marks the position of the primary construction then the additional construction are called as secondary constructions. Then occasionally a secondary construction may be present near the terminal end of a chromosome, separating its small segment called satellite. So there are primary constructions, secondary constructions, satellites. Then the chromosome can be symmetrical or asymmetrical by looking into their length of their arms. So the symmetrical ones possess two equal arms and median centromere, and so the asymmetrical chromosomes or asymmetrical ones possess unequal arms and subterminal centromeres. Then we can classify its relative length of the arms of the chromosomes, position of the centromere, presence of satellites, etc. These are all some characters of taxonomic significance. Then we can talk about the chromosome behavior at meiosis. Significant taxonomic information may be obtained by the study of the behavior of chromosomes during meiosis. Degree of sterility and occurrence of hybridization are determined by the behavior of chromosomes during meiosis. Abnormalities in meiosis, such as non-pairing, crossing over, unequal interchanges or translocations, bridge formation, lagging chromosomes, etc., have all proved to be of systematic value. So, it has a wide importance in cytotaxonomy. So, it is the chromosome behavior at meiosis. Then, these are all about the main characteristic or chromosome characteristics used in most cytotaxonomic studies. Then we can look into the systematic value of taxonomy, or we can see some examples related to cytotaxonomy. Cytological evidence is very important in interpreting classification and establishing relationships. The information collected from chromosome characteristics is valuable at all levels of taxonomic hierarchy. For example, for in family level or generic level or species level, specific level or intraspecific level, etc. At the same time, the usefulness of cytological data varies with different groups. So first one is the cytological variations at family level. When we look into family level, cytological data are very vital in unraveling affinities and interrelationship at family level. For example, uh, it is the cytological data provide a logical basis for the appropriate arrangement of tribes and genera in some families. In the case of family Poaceae, the number and size of chromosomes is the basis of the major subdivisions of this family Poaceae. Then some delimitations of the tribes, like in the case of Asteraceae, it is based on the basis of chromosome numbers. Okay, then the second category is at generic level. So that is the cytological variations at generic level. Uh, its example is that the genus Cystis from the family Cystaceae was formerly included under Helianthemum. However, it is basic chromosome number is 8 and that of Helianthemum is 9. So this supports the recognition of Cystis as a separate genus. So in this case too, the chromosome number made this genus to be separated. Then the third category is the cytological variations at specific and intraspecific levels. Um the example is that the case of two races of Werneria, Vern- sorry, Veronica postrata, Veronica postrata of the family Scrophulariaceae. It has been suggested that they should be treated as two subspecies because the postrata, there were two races in this category. That is, the Veronica postrata had two races. It has been suggested that they should be treated as two subspecies, namely prostrata and Sheareri, because prostrata contained the chromosome number n is equal to 8 and Sheareri contained the chromosome number n is equal to 16. So it is all about the systematic value of cytotaxonomy. Thank you.